UDP header and then the WireGuard protocol. Let me little zoom. Yeah, so hope you can see comfortably. So you can see here, this is the UDP header and then the WireGuard protocol, and that WireGuard protocol is this, this WireGuard header, and you can see this whole thing is around 10 bytes. It is okay. This is the encrypted packet. If you exclude that encrypted packet, which is this, and this is around, it starts here, so it is approximately around 16 bytes. You can see here, the whole UDP ends over here 1D. After that it is the whole WireGuard protocol, and then you can see this is the encrypted packet. Within that WireGuard protocol, it starts with this byte 80, and outside it is starting from this 04. So you can see it is not 10, it is actually 16 bytes. So it is here, and then all the way till here. Okay, see, this is a counter. This is around 8 bytes, I think. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah, this is 8 bytes. And before that, this is some 4 bytes. This is some 3 bytes, and this is 1 byte, so and so. Okay, so add all together, it is around 16 bytes, which is this WireGuard protocol header, and then you have this actual encrypted packet within that. So this encrypted packet is of course nothing but your actual entire stuff within that. So in that case, as you seen earlier, it may be a ping packet, it can be anything else. So what you can do is analyze this, and also you extrapolate with respect to this MTU and then this packet fragmentation. In my case, I have set a specific MTU value which is a sweet spot, far less than the typical 1500 bytes, so that it complies most of the internet public internet networks, and so far it is good. Of course I can't reveal that number. I may keep that as a trade secret, but I kept a specific value. So again, it depends on that aspect. So what you have to do is, if you find your tunnel is not performing well, you capture like this and then evaluate and find out what is the total overhead it may provide. And of course you can apply all this MTU stuff, MTU settings and stuff. Again, there's a specific sequence you should do. The problem with kernel is it will never allow a subset interface to be bigger than or equal to the previous interface. So what I meant is, if you add a bridge interface and add a WireGuard port or something else to that bridge interface, it should be 50 bytes less than that. So as you keep adding them, okay, so some of these are there. Again, I am saying this is somebody who is already working will understand, but this is a sort of out of scope for this video, so I don't want to much go in depth. Okay, I can show perhaps a demo sometime, or if anybody have a doubt, maybe be in touch via mail or in YouTube comments. But as you add any of this virtual ports, say in my case I use also VXLAN and stuff to provide L2 encrypted tunnels, okay, entire L2 tunnels along with in conjunction with WireGuard. So when I do that, the problem is as I keep adding them in conjunction with other tunneling protocol, each time 50 bytes reduces. Okay, so once you set up everything, you can go back and reset these MTUs if the kernel accepts. Okay, so there is something you can step down, but you cannot step down than the previous one. What I meant is, let me explain. See, again I am saying this is not the scope of this video, but I have to cover it because even an MTU is a part of your overall network performance overhead. So say this is your ETH0, your Ethernet port, and this is your typical 1500 bytes. As you add any extra this thing, I mean to say your extra virtual interfaces, and then say you are adding some bridge interface in the middle. Let me put it in different color. You put some bridge interface in the middle and say WireGuard interface in conjunction with something. Technically each step down will be going away like 50 bytes actually. something like that. So this is the diff between this and this, so something like that. So hence if you try doing it, your kernel automatically sets it as, you do this configuration, kernel automatically sets it. And if you want to overrule, or if you want to reduce it further, you want to do any changes, you can do separately again via your typical if config command or anything to set that MTU value or reset that MTU value of your desired choice. So this will be a 50 byte step down. Okay, so that's what. So hence I am saying do this type of packet analysis, and apart from that, of course, you can also see the overall impact of your any of your this thing, your handshakes, yeah, and also this keep alive and stuff. In this case, you can see this is a keep alive, and it is taking a small packet, so it is just 74 bytes. Not a big deal in high speed networks, but it will cause an impact when you consider an LTE type of networks actually. And it will also of course add up costs, especially when you have satellite networks. I quite often got various times, various instances, various customers always want to optimize the satellite networks. And also one of the common complaint about satellite networks are it's very expensive. They always use it as a last line of fallback network. So something fails, if the typical wired network fails, then they may choose to use satellite networks. Other than that, they never use. So because it is very expensive, and it is quite commonly used in European regions, and as well as Middle East and stuff. So this is what, in fact, I went long back to Italy. It's quite commonly used there. Again, the only drawback is it is quite expensive, and hence you need to do some rationing. And also it is not in terms of performance, it is also limited due to physics. Again, you need to optimize your network. So again, as I was pushing forward the WAN optimization, I can consider, yes, it is ideal to optimize further with a proper WAN optimization solution. But in a case if you use any VPN type on those satellite networks, then it is going to further degrade the overall network performance. Hence I am saying take these things into account, and depending on your specific protocol, let's say we search what about OpenVPN, and we see if we can find any samples. Okay, yeah, so you can see OpenVPN header. The only difference is, as I again say, OpenVPN may use turntap interface, and in the case of WireGuard, it is its own virtual interface. Nevertheless, see if in this case, see ISA KMP header and protocol. So just see that specific VPN protocol has what type of overhead is involved. See, in this case, you can see there. But again, it is important for you to just not go with any of these pictures, or go with real data, real packet captures, evaluate what it is, the impact it is causing on this overall network. Okay, come up with a number, like what is the percentage of overhead it is adding to your existing service data, okay, user data. Okay, so which is actually what I meant is this inside red box thing, which is actually the service data it is supposed to carry, but instead we are putting inside a tunnel, and then due to that it is actually causing this overhead. And you observe here, what we are doing is we are actually adding two IP headers, so you can see two network layers. So this is the visible impact of this overhead. You can see there is already a, let me pull this, yeah, there is already a overhead here. This is already there, which is fully equipped to carry a packet, but we are adding this extra entire layer on top with this VPN, and obviously as it does, you need to now fragment this whole stuff, and that is also an issue. Okay, so assume you have, this is the packet, you cannot send, assume this is now 1500 bytes, a proper MTU packet along with L2 header and stuff, something like that. I'm just telling, assume it is roughly around 1500 bytes. So when you want to send something like that, literally what you need to do, you need to construct now 2 packets, something like this. Okay, let's assume you take 2 packets like this, and then take this thing, somewhere here you chop it up, so this makes your first packet, and this together is now, let's assume, is your 1500 bytes. This is your 1500 bytes, or near 1500 bytes. Let me put this tilde. So this is approximately near 1500 bytes, and the rest is this part, this leftover part goes into the next packet or the frame. In this context, yes, it's a packet. So this is the remaining one. So it is essentially doing this. So hence this fragmentation, you can see the amount of overhead it is putting. You need to get this header 2 times, and then it is also cutting short, and it is also making into 2 packets actually. So this is what, so all these things you need to evaluate. I do sometimes do especially consultation requests on this aspect as well in the past, especially this performance, and somewhere there is lot of latency, somewhere there are a lot of drops, and last but not least, you don't ignore the VPN. If you are newly developing the product, first you have a proper prototype, a working prototype, and you keep the tunnel established, and see that there is no tear up or there is no disconnects for a considerable amount of time. See how it performs without any disruptions or disconnects, I mean to say. So in that case, if I see, I always seen issue with VTN. It is highly unpredictable. I'm not sure if all others are facing the same. I felt, and also the project is somewhat not actively maintained these days, as I even discussed in the previous episode. But again, if you see the common used VPN solution is OpenVPN, and of course you have the other options, and now recently this WireGuard, and everybody prefers WireGuard because it is very lightweight, it's kernel driven, it works in kernel space, and it is also lightweight in terms of its the code footprint as well. Okay, it's just not lightweight in terms of its runtime footprint, and its performance is very snappy, and it's I find it is very reliable. It never have any issues like connection disconnects and stuff like that, what I found in the overall VTN project. Again, you need to understand, it's just not the interface alone makes sense, it's the thing how it all put together, and the choreography with the keep alives and stuff, and of course with some compromise such as this kind of overheads. Okay, so hope this video gives you some insight to think about these things. This is again not a video for everyone. I do always prefer to take niche topics like this, so that it helps people like us who are working in the industry to have a common base to discuss some of these deep rooted issues or things, and connect with each other. So this is not, most of my videos are not for everybody. Okay, this is a video meant for someone who is an expert working on this field but trying to improve, or somebody who is doing their masters, or most of the students again who approach me also do some their PhD project or PhD research or some thesis, and then they encounter something and they see that whether they can find a solution and then publish a paper and stuff. So again, you can be that, or you can be just working in a firm as a lead architect or someone, and encountering such issues. Okay, so connect with me, and if you have anything, be in touch via mail, or if it is a very small discussion or a clarification, you can post your queries in YouTube comments. Thanks a lot for joining me. Stay tuned. Have a nice day. Bye bye.